The use of naturally occurring magnetic minerals like lodestone dates back to ancient times. The Greeks and Chinese, among others, observed that certain rocks, particularly lodestone, had the property of attracting iron. They used these rocks for navigation and various mystical purposes. However, have you ever wondered why your fridge magnet sticks to the door but not to the wooden table? The answer lies in the fascinating world of magnetism, a force that has intrigued scientists and laypeople alike for centuries. Today we're going to dive into this exciting topic, demystifying the principles of magnetism and how it influences our daily lives. Magnetism, at its core, is a force of attraction or repulsion that acts at a distance. The magnet in general has two poles, north and south, and the magnetic properties comes from the electron rotation level, so it is never to find one single magnetic pole, and this is one of important difference from electricity. As you know, you can find positive or negative charges separately as well, but this could not happen in magnets. Even if the magnet breaks down in the level of electron, it has north and south poles. Amazing. It's due to the rotation of electrons, resulting in attractive and repulsive forces between unlike and like poles, respectively. Magnetic materials like iron, cobalt, and nickel have a unique property that sets them apart of all metals, and the rotation of electrons will rearrange in one-way direction when approached from magnet. They are attracted to magnets and can be magnetized themselves. That is explained why an iron nail is attracted to an iron magnet, but not to another nail. Two magnets can attract each other. This is because the electrons in these materials spin in a way that their magnetic effects don't cancel each other out. Now imagine a bar magnet. It has a north and a south pole. The space around the magnet where it can attract or repel other magnetic materials is its magnetic field. In general, the magnetic field lines depend on the magnet shapes, but they still have common properties as the electric field lines. Also, we can define the magnetic field lines as the imaginary path of single north pole affected by the magnet strength. Some of magnetic field lines' properties are magnetic field lines seen move out of the north and into the south outside the magnet and from south to north inside the magnet. So the magnetic field lines are closed loops. This is very important. The strength of magnetic field lines in the poles are more of the strength in the middle of the magnet. Magnetic field lines never intersect to each other because this is logical introduction with the basic definition of magnetic field lines. Last, the number of magnetic field lines. Direct proportional with the strength of magnetic field, as these fields are represented by invisible lines, known as magnetic field lines. It consider the Earth magnetic field lines as the following. In the geographically north pole there is south magnetic pole, and in the geographically south pole there is north magnetic pole, so the compass always refers to the north pole. It is attracted with the south magnetic pole as well. They emerge from the north pole and curve around to the south, creating a closed loop, and in any spherical shapes, it is considered the magnetic field lines are uniform in the center and curved around the edges. The concept of magnetic field lines isn't just limited to bar magnets, because there are different types of magnets, such as bar magnet, a straight, rectangular-shaped magnet with a north pole at one end and a south pole at the other. Bar magnets are simple and widely used. Horseshoe magnet resembles the shape of a horseshoe with a north and south pole at the two ends. This design concentrates the magnetic field between the poles, making it useful for certain applications. Ring magnet. Circular or ring-shaped magnets with a magnetic field that typically flows from one face to the other, passing through the center. Disc magnet, circular and flat magnets similar to a coin. Disc magnets are often used in applications where a strong, compact magnet is required, and many more shapes also we can discuss about the magnets types depend on the magnetic properties as permanent magnets. These magnets retain their magnetism once they are magnetized. Temporary magnets. These magnets become magnetic when exposed to a magnetic field, but lose their magnetism when the external field is removed. Soft iron is a common material for temporary magnets. Electromagnets. These magnets are created by passing an electric current through a coil of wire, generating a magnetic field. The strength of the magnetic field can be controlled by adjusting the current. Electromagnets are widely used in various applications, including electric motors and magnetic resonance imaging (MRI) machines. Search about another types of magnets. The magnetic field is very important for our life as it's a protective shield, deflecting harmful solar radiation and playing a crucial role in our planet's habitability. Moving on to the properties of magnetic materials, these can vary widely. Some, like iron, are strongly magnetic, while others, like aluminum, are weakly magnetic. The key to understanding this lies in the concept of domains. In ferromagnetic materials, the most magnetic of materials, the atoms align in regions called domains. When these domains align with each other under the influence of a magnetic field, the material itself becomes a magnet. There are three main types of magnetic materials. Ferromagnetic materials, like iron and nickel, are strongly attracted to magnets. Paramagnetic materials, such as aluminum and platinum, are weakly attracted to magnets. And diamagnetic materials, including copper and silver, are actually repelled by a magnetic field. In summary, the world of magnetism is complex and fascinating. From the basic principles of magnetic materials and magnetic field lines to the Earth's own magnetic field, we've explored a range of concepts. We've delved into the properties of magnetic materials, the importance of domains in ferromagnetic materials, and the different types of magnetic materials. It's a topic that touches our lives in numerous ways, from the humble fridge magnet to the vast protective shield of our planet. So, the next time you see a magnet, remember the incredible forces at play.